Assalamu alaikum. Inshallah, we'll solve practice problems on the law of conservation of momentum to predict final velocities of objects after collision given their initial velocities. So the first question says each croquet ball in a set has a mass of 0.5 kilogram. The green ball traveling at 12 meters per second strikes the blue ball, which is at rest. Assuming that the balls slide on a frictionless surface and all collisions are head-on, find the final velocities of the blue ball if the green ball stops moving after it strikes the blue ball. So I have a collision. There is a good simulation on FIT regarding this one. It's here. So I have two balls actually. Both of them, they have the same mass. Now, I can here play with the mass. I can make the mass 0.5 as the question. And the other one, I can make it the same, 0.5. And I'll start, you can see here their velocity. The first one is moving with velocity 1 meter per second. And it has a momentum. How I'm going to find the momentum? Always momentum is mass times velocity. So 0.5 times 1, it will give you 0.5. Now, the other object is stationary. It means at rest, not moving, which means its velocity is 0. Now, if I hit play, now this one, it will hit the other velocity. This one, what will happen to it? It will stop. So the first ball, the red ball stops and the other one continue moving in the same direction. Now, momentum before equals always momentum after. This is a conservation of momentum. Momentum before, you remember, it was 0.5. Now, momentum after, if I multiply the velocity, which is 1, times mass, which is 0.5 for the green velocity, for the green ball, it will give you 0.5. Add the momentum after, 0.5 plus 0, it will give you 0.5. So always momentum is conserved. Now let's go back to our question. Now the easiest way to solve this question is to make a table. Okay, now okay, so I have here first mass and I have it is velocity, and I calculate the momentum. So when I draw a table, most of the time we're dealing with two objects. So I have object one, which is the green ball, and I have object 2, which is the blue ball. Before the collision and after the collision. Before the collision, I have one was stationary moving and the other one was moving with a velocity, and it will hit this one which was not moving. Now the velocity for the second object is 0 because it's stationary. Both of them, they have the same mass, which is 0.5, 0.5. The initial velocity for the first one, 12, so I write it here, 12. And then I calculate the momentum. How am I going to calculate the momentum? M1 times V1. This is the momentum. 6, of course, a unit, kilogram times meter per second, but I don't care now to write the unit in the table. I just need to find values and I have to make sure all my values in SI units. Now let's go to the second object. It is mass, again is the same mass, 0.5, and its velocity is 0 because it's not moving. What is the momentum? You multiply them together, the momentum is 0. Now this is after, this is before the collision. Now after the collision, what will happen? Find the final speed of the blue ball if the green ball stops. So the green ball, it is velocity 0 because it stops. Now the blue ball continue to move with final velocity, I don't know. So I will write it as simple. V2, second object, final velocity, which is I don't know. How am I going to find the momentum? Mass times velocity. I'm going to write it here on the table, which is 0.5 times V2 final. Now, and then I'm going to write what? The conservation of momentum. Conservation of momentum, P before or initial equal P after or final. Now, P before, you add all the momentum. You see the red one? The initial momentum is 6, plus the other initial momentum is 0, so 6 plus 0, this is before, equals P after. Now, P after, the red one again, this is after. P for the first one is 0 because it stops. For the second one, it's 0.5 V2 square. Now, I need to find V2 square. Now I have equation. I will solve it to find VT square. It will be 6 divided by 0.5, and I'll get the final answer in meter per second. Okay? Now, let's solve another question. Now, the other question now, you have 63 kilogram, just I need to use the pen, astronaut is on a spacewalk when the tether line to the shuttle breaks. Now, the astronaut is able to throw a spare 10 kilogram oxygen tank. Now, you have two objects now. Astronauts is the first object. The astronaut, at the beginning, he was carrying a tank, oxygen tank. So at the beginning, both of them, they were not moving. They will have the same momentum, 0, because they were not moving. Now he throw this tank away, throw it away, and it has a speed, okay? Propelling the astronaut back to the shuttle. Yani he will go back, he will be pushed back to the shuttle, assuming the astronaut start from rest. With the respect to the shuttle, find the astronaut final speed with the respect of the shuttle. Now again, I'm going to do my table. Okay, so I have two objects. First object, it's my astronauts, and second object, it's his tank. And I will write in the table initial or before and after, which is final. Okay, now I have M1, I will write the masses. M1 for the astronaut, 63, and he was not moving, so it is initial velocity 0. I have to find his momentum, it will be 0, M times V. Now, for the tank, start to move with 0 velocity, but, sorry, its mass is 10, and again, it was not moving because both of them, the astronaut was carrying actually the oxygen tank. So it is velocity 0. So P2 will equal 0, mass times velocity. Now, this is before. Now, after. Now, what will happen after? Now, the astronaut will go back. After he throw his tank, after the astronaut throw his tank, he will go back. He will throw it forward, but he will go back because it's heavy. Now, I need to find his final velocity. I don't know it. Its mass will not change. His mass will not change. So, momentum again, mass times velocity. I have to write it and I change the color because all the red colors, I'm going to use them in solving the problems. Now, let's go to the tank. Its mass doesn't change, 10. Now, it is velocity. It moves with velocity, what? 12 meters per second. Momentum, it will be mass times velocity. So what I'm going to do again, I will write the conservation of momentum. P before equal P after. I'm going to add all the ones here in the initial one in the red. What I have in red, I have 0. Plus 0, so it will give you 0. Now I'm going to final. I'm going to add again the one in red. So final momentum, 63 times V1 final plus 120. Now I need to find V1 final. Now it's math. I have to solve the questions. Take this to the other side. It will be negative 120. I need to get rid of 63 next to V1 final. So the opposite of multiplication, because 63 times V1 final is multiplication. The opposite is division. So I'm dividing by 63 and I get the final. Now remember, in negative, it's a direction. So that means the speed of the astronauts is 190 in the opposite direction. in the opposite direction. Now I still have other two questions. I will solve them in the next video, inshallah.